Hello class 12. Good morning. How are you? You all know that we were discussing about the topic electrochemistry. And yesterday we have discussed about primary cells. Now, today we are going to discuss about secondary cells. We know that secondary cells, also known as secondary batteries. Secondary cells are those which can be recharged. We use them over and again. After using them, we charge them and again we use them. Like mobile battery is rechargeable. Even the batteries which we use in our bikes or cars, that is also a rechargeable batteries. So we have few rechargeable batteries. One of them is very important, that is called lead storage battery. So first we will discuss about lead storage battery. Keep in mind, it is one of the most important topic which definitely comes in exam. Now let us see the lead storage battery and let us see what kind of reactions takes place in lead storage battery. Lead storage battery is commonly used in automobiles as well as it is used in cars. In this lead storage battery, we take normally 6 electrodes which makes 6 different types of cells. Each cell has a voltage of 2 volt. So normally the cell, the lead storage battery which we use is either 6 volt. For 6 volt we need 6 electrodes and for the 12 volt we need 12 electrodes. Out of 12, 6 acts as cathode and 6 acts as anode. And keep in mind, each pair of electrode produce 2 voltage battery. 2 voltage. And now let us move towards secondary cell, that is lead storage battery. Let us see what happens. In lead storage battery, there are 2 different kinds of electrodes. One is anode, which is made up of lead plates filled with spongy lead. Keep in mind, anode, it contains spongy lead. It means lead in its, we can say, paste form. It is covered inside or placed inside the lead electrodes so that the process to be carried out fast. Now, cathode. The lead grids filled with lead dioxide. It acts as cathode. So keep in mind, in lead storage battery, we have 2 different types of electrodes, anode and cathode. Anodes are basically lead plates filled with spongy lead and cathodes are the lead plates filled with lead dioxide. And the electrolyte is dilute sulfuric acid. You have seen that mostly in lead storage batteries we need to add water over and again. Why we add water? Why do we add distilled water? The reason is being, if you see the reactions occurring at cathode and anode, here we are getting lead sulfate in solid form. Lead sulfate, it gets deposited on the walls. So to dissolve them back, we have to add water. Now, the reactions during discharging. When the cell works, the cell gets discharged. The reaction which takes place, the reaction as anode. We know that anode oxidation takes place and here anode is lead plates filled with lead, that is spongy lead. So lead, it reacts with sulfate ion, form lead sulfate and release 2 electrons. These 2 electrons move in the outer surface, or we can say that outer circuit. So when electron moves in the outer circuit through the wires, current flows. Now the reactions at cathode. Cathode is copper plate filled with lead dioxide. So lead dioxide, it reacts with sulfate ions in the presence of H positive ion which comes from sulfuric acid, gain the electrons, form lead sulfate and releases water. So when we write the overall reaction, lead, that is solid, plus lead dioxide solid plus 4H positive and 2 sulfate ion means H2SO4 gives lead sulfate plus 2 molecules of water. So again at anode lead react with sulfate on lead sulfate release 2 electrons. These 2 electrons goes to the cathode and at cathode lead dioxide combined with sulfate ion in the presence of acid form lead sulfate and release water. So lead storage battery is rechargeable. These are the reactions which acts during discharging of battery. When we recharge or when we put in electric circuit for recharging, these reactions takes place but in a reverse order. That is what we call reverse reactions. So these are the reactions during discharging, and now let us write the reaction during charging. The same reactions but they takes place in opposite direction. So let us write those reactions in reverse order. Now the reactions during recharging. You can see the reactions during recharging are just the inverse of the reaction which were acting during discharging. Cathode changes to anode and anode changes to cathode. Here you can see the reaction at cathode. PbSO4 gains 2 electrons from lead solid plus sulfate ions. And PbSO4 solid react with 2 molecules of water to form lead dioxide plus sulfate ions plus H positive ion plus 2 electrons. When we write the overall reaction is 2 PbSO4 plus 2 molecules of water gives lead solid plus lead dioxide solid plus sulfuric acid aqueous. If you compare the reaction during charging with the reaction during discharging, you will find that they are just the inverse of each other. Cathode changes to anode and the anode changes to cathode. So this is lead storage battery, and we have seen the reactions occurring at cathode as well as at anode during charging and discharging of lead storage battery. Now let us move towards another very important cell which is known as nickel cadmium cell. This cell is quite popular these days. This cell is normally used in calculators. Question comes, name the cell which is used in calculator. This cell which is used in calculator is NiCad, that is nickel cadmium cell. It has a voltage of around 1.4 volt, but this cell is quite expensive, but its life is long. It lasts for a longer period of time as compared to other cells. So, nickel cadmium storage cell, it contains anode made up of cadmium, cathode or metal grade filled with nickel 4 oxide, that is NiO2. Cathode is metal grade filled with nickel dioxide. Electrolyte is KOH. Both the electrodes are immersed in KOH. And the reactions which takes place. We know that at anode oxidation takes place. So anode is a cadmium electrode. So cadmium, it gains 2 OH negative ion from the electrolyte KOH to form cadmium hydroxide, releases 2 electrons. These 2 electrons move towards cathode in the outer circuit, hence current flows. They reaches at cathode, nickel dioxide which is inside the metal grids, it reacts with water, gain the electron, form nickel hydroxide and releases 2 OH negative ions. So these are the reactions which takes place in nickel cadmium cell. The potential or the voltage is 1.4 volt. Keep in mind this cell, that is nickel cadmium cell, is used in calculators. After doing nickel cadmium cell, keep in mind it is a secondary cell. Now we are moving towards a very important cell which is called fuel cell. Keep in mind the fuel cell was used in Apollo rockets. So sometime question comes, name the cell which is used in Apollo rockets, that is fuel cell. Now we are going to discuss about fuel cell, that is fuel, F-U-E-L, fuel cell. Fuel cell is the best cell. It has an efficiency from 60 to 70%. But the problem is fuel cell is quite large in size. We need to supply hydrogen and oxygen separately from outside. Let us see how this fuel cell works and what are its advantages and disadvantages. Now, we are going to discuss about the fuel cell which was used in Apollo space shuttle. The water produced in this fuel cell was used by the astronauts for drinking purpose. And let us see what happens and what kind of reactions occurs in fuel cell. A fuel cell generally contains two types of electrodes. One electrode is cathode, which is made up of porous carbon with suitable catalyst. Similarly, the other one, anode, is also made up of porous carbon with suitable catalyst. It means both the cathodes and anodes are made up of porous carbon and it contains suitable catalyst. And in these two electrodes we place a highly concentrated, or we say highly corrosive sodium hydroxide as well as sodium hydroxide or KOH. Out of these two strong alkali, one is used. Either we use strong alkali KOH or we use strong alkali NaOH. The water produced after the reactions is used by the astronauts. The water, it goes out. Now this is the diagram of the fuel cell. You can see here we are supplying oxygen continuously from outside on cathode side and hydrogen is supplied from the anode side. Now the reaction which takes place. At anode, of course, oxidation will take place, and anode we are supplying hydrogen. Hydrogen combined with hydroxide ions from the solution, from the alkali, form water, releases two electrons. These two electrons moves in the external circuit towards cathode, where oxygen gains two electrons to form hydroxide ions. The overall reaction, when we write, we combine these two, 4 electrons, and here we have 2 electrons, we balance it, and the overall reaction is 2H2 plus this 4OH get cancelled, here we get 4 electrons. 4 electrons got cancelled, we get 2H2 plus O2 gives 2H2O. So 4H2O, 2H2O, it got cancelled, we get 2H2O. The reaction is very simple. H2 plus O2 gives 2H2O. Keep in mind, it is a clean cell. It do not produce any kind of pollution. Efficiency is delta G upon delta H, which is found to be 83%, which is quite high. So you can see the diagram of the fuel cell. The reactions taking place at cathode as well as anode. Now advantages, this is a clean fuel, means it is a clean cell, does not produce any kind of pollution. Second advantages, it has a very high efficiency, but it has some disadvantages. First, the corrosive nature of KOH and sodium hydroxide is difficult to maintain. Second, it requires a continuous supply of hydrogen and oxygen from the outside, which is quite difficult. Third, it is large in size, difficult to use in small apparatus. And keep in mind, fuel cell is the best cell with highest efficiency till now known. Biggest advantage, it can never be dead. We have to supply hydrogen and oxygen from the outside. Till the time we supply, it works continuously. So, we have done fuel cell. Now, let us discuss a very important concept, that is corrosion. What is corrosion? Slowly eating up of metals by the atmospheric conditions is called corrosion. Rust is an example of corrosion. Rust word is used for corrosion of iron. Question comes, show that rusting of iron is an electrochemical process. Why rusting of iron is an electrochemical process? Explain. Now you can see here, when we talk about corrosion or rusting of iron, rust, it is a brown color substance which we obtain on the surface of the iron due to its reaction with oxygen and moisture. Here you can see mechanism of the reaction. Water, when it comes in contact with carbon dioxide from the atmosphere, it forms carbonic acid, H2CO3, which acts as a catalyst. Or we say that H2CO3, it acts as an electrolyte. Sorry, it's not a catalyst, it's electrolyte. So water combined with carbon dioxide form H2CO3. This carbonic acid, it dissociates to form hydrogen ion as well as carbonate ions. You can see this is a surface of iron. On the surface of iron, when we have a water droplets and oxygen, this oxygen it acts as cathode and this is iron which acts as anode. So carbonic acid breakdown form hydrogen ion and carbonate ion. The reaction at anode. When this carbonic acid falls on the iron surface, iron start behaving as anode. So iron, it loses 2 electrons, form Fe2 positive. And at cathode, oxygen combined with water, combined with hydrogen ions and electrons to form water. So these are the reactions which taking place at anode and reactions at cathode. At anode, iron loses 2 electrons. At cathode, oxygen gains electrons to form water. So the overall reaction, when it takes place, we get 4 Fe2 positive, O2 plus 4 H2O gives Fe2O3. These Fe2O3, when combined with X molecules of water, it forms rust. The formula of the rust is Fe2O3 dot X molecules of water. So this is a diagrammatical representation how it acts as electrochemical cell. You can see here, during the rusting of iron, the electrons are getting transferred. Since one acts as cathode, other acts as anode, it means it is a redox reaction, and redox reactions means it is an electrochemical process. Here, 2 electrons have been lost by iron. Here, oxygen gains the electrons to form water. It means transfer of electrons takes place. Hence, rusting of iron is an electrochemical process. So, this is how the rust of iron takes place. The rust has brown color. Now, you have done how the rusting is to be prevented. We have various methods to prevent rusting by applying grease, by applying paint, galvanization, electroplating, etc. So with this, we have finished the chapter. So you all are advised to just go through the chapter completely. If you find any difficulty, you can contact us. So till the time, just revise. Thank you. and have a nice day.